Endogenic process. What is endogenic process? It is associated with the energy originating in the interior of the solid earth. The ground we live on is what moving all the time, and the forces within the earth is called the endogenic process. So our planet Earth is a dynamic and ever-changing place. While we often see the effects of weather and erosion on the surface, powerful forces deep within the earth are constantly shaping its features. So these internal forces, known as the endogenic process, are responsible for the creation of mountains, volcanoes, and even the continents themselves. So in this presentation, we will delve into the fascinating world of endogenic process, exploring their different types and the driving forces behind them and their profound impact on the Earth's landscape. What are the endogenic processes? Endogenic process refers to the geological process that originates within the Earth. This process occurs in the Earth's interior, primarily in the mantle and crust. They are driven by the immense heat generated in the Earth's core. Endogenic processes are responsible for the large-scale movements of Earth's crust and the formation of major landforms. So the endogenic process stands in contrast to the exogenic process, which are the external forces that shapes the Earth's surface, such as the wind, water, and the ice. So unlike the exogenic process that works on the surface, the endogenic process originates deep within the Earth. So the tremendous heat emanating from the Earth's core sets these internal forces in motion. So these forces cause the movement of tectonic plates, the molten rock beneath the Earth's crust, and the influence the formation of mountains, volcanoes, and other significant geological features. So where does the Earth's internal heat come from? This driving force is the thermal energy of the mantle. Most of the thermal energy originates from the decay and disintegration of the radioactive elements in the Earth's core. So, there are two main sources contribute roughly equal amounts of the heat Earth's interior. We have the Earth's internal heat is not an infinite resource, but it is a vast reservoir that has been driving geological process for billions of years. So the two primary sources contribute to this internal heat, which is the first one. We have the primordial heat, or it is when the Earth formed roughly 4.5 billion years ago. The intense gravitational compression generated tremendous heat. So it is a significant portion that remains trapped within the Earth's interior, contributing to its current temperature. Next, we have the radioactive decay. It is a certain element deep within the Earth are naturally radioactive. As these elements decay over time, they release a energy in the form of heat. Radioactive decay of elements like uranium, thorium, and potassium in the Earth's crust. And the mantle is an ongoing source of internal heat. So the combined effects of this primordial heat and the radioactive decay, it maintains the Earth's interior and the high temperature, driving the process like plate tectonics and the volcanic activity. There are main types of endogenic process. We have the plate tectonics, mountain building, and the volcanic activity. The plate tectonic, it is the theory that the Earth's crust is divided into rigid plates that move slowly over the mantle. The mountain building, it is the process by which the mountains are formed through the collision and the uplifting of tectonic plates. Volcanic activity. The eruptions of molten rock, ash, and gas from the Earth's interior. So, ang endogenic process can be broadly categorized into three main types. We have the plate tectonics, this is the overarching theory that explains the large-scale movement of the Earth's crust. So the crust is divided into massive rigid plates that glide over the hot plastic mantle below. So the movement of this plate causes them to collide, diverge, or subduct, meaning it is a one plate sinking beneath another. So these interactions create a mountain ranges, rift valleys, and influence the volcanic activity. And the mountain building, it is when the tectonic plates collide, the immense forces compress and push the crust upwards, resulting in the formation of mountains. So these different types of mountain ranges arise depending on the nature sa collision. And the volcanic activity, volcanoes are essentially vents or openings in the Earth's crust that allows the molten rock or the magma from the mantle to erupt onto the surface. The volcanic activity can be explosive or effusive depending on the composition of the magma. Forces driving endogenic process. We have the convection currents. It is the primary driving force behind the endogenic processes. Heat from the Earth's core causes the mantle to rise in hot plumes, cool down, and sink back down. So this continuous circulation of hot and cool mantle rock creates convection currents. So the engine behind the endogenic process lies deep within the Earth's core. So the immense heat that it is generated there that sets the stage for a phenomenon called the convection. So kaning hot, less dense material in the mantle rises, while ang cooler, denser material mo sink. So this continuous circulation of mantle mag-create siya convection current. Similar po siya sa boiling water in a pot. So this current exerts tremendous forces on the tectonic plates, causing them to move and interact. So this convection currents that influence siya sa location and activities sa volcanoes. So areas where hot plumes rise from the mantle are more likely to experience volcanic eruptions. Impact of endogenic process. Formation of the landforms, distribution of continents and oceans, mineral deposits, earthquakes, and tsunamis. So the formation of major landforms, it is mountains, plateaus, and ocean basins are all shaped by these endogenic processes. Distribution of continents and ocean, it is the movement of the tectonic plates has determined the current configuration of the continents and ocean. So ang endogenic process have a profound impact on the Earth's landscape. So the movement of tectonic plates and volcanic activity are responsible for the formation of the major landforms like mountain, plateaus, and ocean basins. So these continents themselves are constantly shifting due to the plate tectonics and the current configuration of land and sea is a result of this ongoing process. So these endogenic processes, it has a distribution of a valuable mineral deposit. So the volcanic eruption and hydrothermal vents on the ocean floor can concentrate minerals, creating economically important resources. However, an endogenic process, it can also create a destructive consequences. So the movement of tectonic plates can cause earthquakes and sudden shifts underwater can trigger devastating tsunamis. Igneous activity. Igneous activity is a broad term encompassing all the geological process that involves the movement and solidification of magma or lava. Also, it can be further categorized into the three main types. We have intrusive igneous activity, extrusive igneous activity, and the hypabyssal igneous activity. So now the intrusive igneous activity, or so-called the plutonianism, it is when the magma doesn't reach the surface and cools and solidifies within the Earth's crust. It forms a large coarse-grained igneous rocks formation called the plutons. So examples of intrusive igneous rocks, we have the granite and the diorite. Next, we have the extrusive igneous rocks activity, which is the volcanism. So this is a familiar process where magma erupts onto the Earth's surface through the volcanoes. So as the magma cools and hardens on the surface, it forms extrusive igneous rocks like basalt and obsidian. So the volcanic eruptions can be spectacular and destructive, but they also play a vital role in shaping the Earth's landscape. The hyperbasal igneous activity, this category falls somewhere between the intrusive and extrusive activity. So when the magma cools and solidifies relatively shallow depths within the Earth's crust, it forms the igneous rocks with the characteristics of both types. So these rocks, such as we have the pegmatite, can have a wider range of grain sizes compared to purely intrusive or extrusive rocks. So understanding these different types of igneous activity, it helps us to appreciate the various ways molten rocks interact with the Earth's crust and diverse geological features it creates. We have the three main types of the endogenic process. So the three main types of the endogenic process, we have the magmatism, the metamorphism, and the volcanism. So we will explore the three main types of the endogenic process. Yes. So magmatism. Magmatism refers to the geological process involving the movement and solidification of magma or the molten rock within the Earth. Magma forms deep within the Earth's mantle where high temperature cause rock to melt. Depending on where it cools and solidifies, magma can give rise to different types of igneous rock. So magmatism is the fury engine that drives many geological phenomena. So deep within the Earth's mantle, the immense heat causes rocks to melt, forming a molten rock called the magma. So this molten material is less dense than the surrounding solid rock and begins to rise. So as the magma moves through the Earth's crust or erupts into the surface, it cools and solidifies, forming an igneous rock. So the location where the magma cools determines the type of igneous rock that forms. Intrusive igneous rocks solidify within the Earth's crust, while the extrusive igneous rocks from when the magma erupts on the surface. Next, we have the metamorphism. Metamorphism refers to the transformation of existing rocks or the protolith into a new type of rock due to the intense heat, pressure, or chemical activity. Metamorphism can occur without melting the rock. The intensity of heat, pressure, and chemical activity determines the degree of metamorphic change. So metamorphism, it is the process where the existing rock undergoes a transformation into a new type of rock. Unlike sa magmatism nga nag-involve siya og melting sa rock, ang metamorphism occurs in the solid state. So the intense heat, pressure, or the combination of both can trigger the metamorphic change. So ang original rock, it is called the protolith. It is subjected to these forces often deep within the Earth's crust or near the tectonic plate boundaries. Pero nakadepende na po na siya sa intensity of the forces. So ang protolith, it can recrystallize, develop new minerals, or change its overall texture and structure, resulting in a new metamorphic rock. Last but not least, we have the volcanism. Volcanism refers to the process of eruption of molten rocks, or the so-called magma, ash, gas, and onto the Earth's surface. So volcanoes are vents or opening in the Earth's crust that allows the magma to reach the surface. Volcanic eruptions can be explosive or effusive, depending on the composition of the magma. So the volcanism, it is a spectacular and sometimes destructive consequences of magmatism. When magma rises through the Earth's crust, and find a pathway to the surface, it erupts as the volcano. So volcanoes act as a vent or opening in the Earth's crust, allowing the magma, ash, and gas to escape. So this type of volcanic eruption depends on the composition and viscosity of the magma. So if less viscous, the magma tends to flow more easily, resulting in effusive eruptions with lava flows. More viscous magma can lead to explosive eruptions with a violent release of ash and gas. So volcanic activity plays a significant role in shaping the Earth's landscape and has a profound impact on the environment. So, to put it simply, our study into the endogenic process tells us an exciting story of an Earth that is continuously changing. So the invisible process that constantly change our world are the volcanism, metamorphism, and the magmatism. So these ferocious eruptions of volcanoes and the tall mountains formed by the metamorphic process are example of how these internal forces have had an impact on the Earth that we live on today. So gaining an understanding of this process enables us to recognize the changing nature of our planet and continuous geological activity that shapes its surface. So studying this process can help us to better understand the amazing strength of our planet Earth and help us to get ready for any geological threats that may arise in the near future. Thank you.